So this is the final demo for the sound engine. It's a setup of 5 different demos in the project. So you can run all the different ones. They're just keyed to 1, 2, 3, 4, 5. Right here is where I load all the sounds. All of them but Beethoven are loaded because Beethoven will be showed for async loading. But for now, all of them are loaded. What you do is you say sound IDs. This is the name I want to call it on the game side, and this is the actual name of the file so that the engine knows exactly what it should be loading and tying to the sound name. So that's just loading all those sounds. If we go here in the demo 1, the way that a sound is set up is you basically make a playlist. I'm going to make a playlist with just one sound here. It's going to be the sound fiddle, and then I'm going to call it playlist fiddle because it's only got the one sound. I'm going to load that playlist into 2 sounds and then load the other one into this sound. So these 2 sounds are going to play this playlist, this fiddle playlist, and this one's going to play the bassoon playlist. Then I'm going to say play A1 now, pan A2 to the left, and then play it in 3 seconds, and play in A3 to the right and play it in 6 seconds. So this is going to say play now. This one is going to say set the pan of the sound to the left, but then actually play it in 3 seconds. So this is going to say in one package, when you say play, it's going to set the pan. It's going to send a command that's going to, in 3 seconds, set the pan and play the sound. Same goes with the other one. Most of the rest of the demos on the game side have timers that say, hey, do this now, do this now, do this now. For the beginning here, I just wanted to show that you can say play a sound in 3 seconds, and the audio engine will take care of that for you. But just to demonstrate how this works, to explain how this works, basically you can say whenever you say play, it sends a package to the audio engine. So I'm saying set pan before play, which means on the game side I'm going to save the fact that you want that pan to be to the left, but then I'm actually going to tell the audio engine when you say play. So if I were to say play and then set pan, I would have to send 2 packages to the audio engine because I would have to tell the audio engine, hey, he wants to play this, oh, and he wants to set the pan of it to the left. Whereas if you do it the other way around, I can say, oh, you want to pan this, oh, and now you want to play it, okay, well, play it with all these attributes. So it's better to say set pan first. But then, like I said, here's all the other things. I'm going to go ahead and run the project, and I'm going to turn the volume down here because it can be very loud, and I'm going to try to explain exactly what's going on while the demo is playing. So demo number 1 is going to play a lot with just panning and basic attribute changing. So first it's just playing center, then it's going to play one on the left, play one on the right. Next it's going to pan a sound from the left to the right. Then we're going to pan a sound from the right to the left. Then we're going to change the volume of sound from 0 to 100. And then 100 to 0. Next it's going to play a sound on the left and one on the right, and then I'm going to print out how long those sounds have been playing. These are 2 mono sounds, one's on the left and one's on the right. There it's just printed that the sound on the left has been playing for 5 seconds, then 8 seconds. And just stop the sound on the left. Now I stop the sound on the right, and then it's going to print how long the one on the right's been playing. And the next one's going to start 4 sounds really quickly in a second and a half, and then it's going to stop 3 of them. That's the end of demo 1. Demo 2 is a priority demo, so what the priority demo does is it tries to play a bunch of sounds, and the priority system keeps track of which sounds can be played and which ones are allowed to. The output window is going to make a better job of explaining this than I can with words, so I'm going to play the demo first, and then I'll explain it. So as you can see, it starts off here and I'm playing 3 sounds, one at 10 seconds, 50, and 150 seconds. Then I add a 50, add a 75, and add 100. So now we're at 6 sounds, which is the max for the engine in this demo. So then I add another 150, which kicks out the other 150 sound. Add a 75, which kicks out the other 150 sound, because that's the lowest priority. Add another 75, which kicks out the 100. add another 75, which kicks out this 75 because it's been playing for the longest period of time. Then I try to add 150 priority sound, which doesn't even get added or played because it's too low of a priority. Then I stop all the sounds. And just to demonstrate that this is actually the active table, I'm going to play the priority system twice really quick, and you'll see that it's going to be a table made up of 2 10 priority sounds and 4 50 priority sounds, and all the 75, 100s, and 150s are going to be kicked out. As you can see, the active table is made up of only 10s and 50s because at the beginning I'm creating a 10 priority and 2 50 priorities in both of those systems, and they're going to override all of the 75, 100s, and 150s. So the next demo is a stitching demo. So demo 3 here. It's pretty simple. All that it does is it creates the demo and plays one sound. The sound has one playlist, so I have this playlist called Seinfeld. I've loaded 8 different sounds, and I'm going to add all of these sounds into the playlist. So I'm going to say play the intro, then A to B, B to C, C to A, and end. So I have this one playlist with 8 sounds. I'm going to say I have a sound called playlist, make it a new sound with that playlist. I'm going to give it a callback. This is purely just because I want to be able to end and destroy this demo when it's done playing that playlist. Then I'm going to set the Seinfeld volume to 80, and I'm going to play the sound. So I'm going to say that play the sound now, which is at 0 seconds. Don't loop it. Play it with 50 priority, because that's generally what I like to play things at. And then give it this callback just so I know when it's over. So we're going to go ahead and run the Seinfeld demo, just demo 3. So as you can see down here, it's playing when a sound's been stitched in. This is happening on the X audio side because when a sound ends, I actually come into this callback, which is the X audio callback, and it says, well, should there still be, is there more sounds that you want played in this playlist? And it's saying yes. So it's going, and it's right here. I just have it like a debug printout that's only for the demo. That's basically saying, hey, which sound are you trying to play right now? And just print out, I've stitched that sound. So basically what happens when you have a playlist of multiple sounds is that you play a sound, it plays that sound on an audio file. It then, at the end of the audio file, calls the callback, and it says, is there more you want me to play? It adds another buffer back onto the same voice, and it continues on and does it again and again and again. So what happens is when a buffer ends, it adds another buffer, buffer ends, add another buffer, until it gets to the end of the playlist, and then at the end of the playlist it'll say, hey, do you want me to loop that? Which if you say loop, it'll go back to the beginning of the playlist, play the whole playlist again, and then it will say, do you want me to loop it again? Yes or no, based on how many times you said to loop it. If not, then it will destroy the sound. So the sound keeps the same priority, volume, everything that's been set. If you try to change it, it'll set this same voice, which makes it a lot easier. I can play it one more time without talking over it really quick for a couple of the transitions, just so you know that it actually is smooth too. Alright, so as you can see, it's seamlessly stitching together. So then we got demo 4. So what demo 4 is a game user callback system. So let me just pull up these really quick. Seinfeld's still playing there. So I created 4 individual callbacks, one for each of the sounds that get played during this demo. So there's callback A, B, C, and D. And what they are, they're a public callback base, and they use this override of sound ended. So what's happening is when I create this one, I just get a reference to the sound so that I can get the how long it's been playing, its ID, and its pan for when I want to print. But basically when the sound ends, I just print which sound it is based on which one I know I'm giving it to. And then I say, well, how long has that sound been playing? How long has, what is the ID of that sound, and what's the pan value of that sound? So it's going to play 3 of them, and then it's going to play one more a couple seconds later. Let's just go back in here. So as we ended there and it did the callback. Another one ended and did the callback. That one ends, does the callback. The other one's still playing on my right, so all those three played on the left. And when this one ends on the right, it's going to end that sound. It's going to give its callback. And all of this was programmed on the game side, so all these are game side callbacks, not the audio side callbacks. So on the game side, I'm printing all these values. So that's game side callbacks. Basically, the way you set that up is you just say, create a callback, and then when you say play, you can give it a callback that you want it to play with. So I'm basically saying, play it now, don't loop it, with 50 priority, and give it this callback. Okay, and then we go on to demo 5. Demo 5 is an async loading demo. So what this demo does is it will load up 2 playlists, one for electro, one for alarm. It's going to create those sounds. Then I'm going to say play this alarm sound, or sorry, the electro sound, played on the left. So it's going to play the sound on the left. Then I'm going to say create this game loading callback. So the game loading callback is just another public callback base, but I'm going to use the audio loaded callback instead of the other one, instead of the voice ended callback. So what this does is it basically allows me to get the callback to the game side when the audio is done loading. So I'm just going to print out that the wave has loaded. This is a game side callback, remember that. So this is all done by the user. And then, so I'm basically saying play this sound, then I'm going to say load Beethoven, and then play the other one. So what this is showing is you can play a sound. When you say load a sound, it's not going to stall this sound, but it's also not going to stall until to playing this sound. So all you're going to hear is this sound playing and this sound playing at the same time, but this will also be started loaded in between. And then at 43 seconds, I'm going to play Beethoven to prove that it has been loaded. So here we go. So as you can see down there, it was loaded. Both the alarm sound and the other sound started immediately, and there wasn't any stall on the game side, and there wasn't any stall when the sounds finished loading on the audio side either. So this is going to keep playing until 2 seconds and hit the Beethoven sound, so then it's going to stop the other sound and play Beethoven. Crank that up a little bit for you, but there you go. There's all the demos. So all the demos run when you're playing it once. You don't have to stop in between to like unload stuff. The way that the whole system works is basically when you say play a sound, it sends a package to the audio side. You can say play now and play later, but if you say play now, what it's going to do is it's going to go to the audio thread. Sorry, it's going to say stay in the game thread, and it's going to say, hey, is the priority of that sound high enough to be played, or is there even just open sounds? Because if there's just open sounds, then go ahead and play it. So what's going to happen is it's going to play the sound. So when I say play it, like the first sound, it's just going to go and it's going to say, can I play this? Yes. Go ahead and play it. It's going to add it to the priority list, and the audio side will take care of playing the sound. So the audio side then will create an audio source, and then it will load that data with the file that you want. So the audio engine, when you load a file, it basically says, hey, does that file exist? If it exists, then get a buffer. So there's only one buffer in the buffer manager, but the buffer manager just keeps track of that one buffer. So I basically get that one buffer, I load it with the information from the file, then I give it to the audio source, and I load the audio source with that buffer. Then I give pointers to all of the audio files that I'm pointing to make sure you don't try to unload one of those files while it's being used by an audio source. So I'm basically reference counting all the different audio files you're using, and then I clear that buffer because you only need the one buffer and it's been loaded, so I don't need that buffer doesn't need to be attached to that audio source. Then I return that audio, and that audio gets played, or whatever the command wants to do with that audio. So basically, the priority system works how if you're on the game side, I'm going to say, can I play this sound now? And it's going to say yes or no. It's going to return immediately if it's too low of a priority, or if it played it. If you say play later, it'll let you do it, but it'll always just say success, saying basically I will try to play this later, and then the audio side will do a priority check with the current active sounds at the time that you said. So you can say play later, you can play now. Same with any of the sounds, volume changes, pitches, all that. You can say do it later. You don't have to do it right now. But if you do it later, it's going to make sure that sound's still playing, stuff like that, to make sure that you didn't delete that sound in between or remove that sound in between. The other thing that is nice is audio sources are reusable. So there's only 6 audio sources. So basically what's happening when I say play a sound, because there's 3 different commands. When you play a sound, there's play a command, which is just going to say, hey, I know that there's only like 2 or 3 sounds playing. Let's say 3. There's 3 sounds playing. So play a fourth. It's going, and the audio side is going to say, okay, well, have I created 4 sources? Or is there any sources that aren't being used anymore? Like, have I played 5 at some point? So there's a 5th source just sitting in a recycled list that I can just take that list, take it off that list, give it all the data I want, and play that one now. Or do I want to create one? Because it'll create up to 6. But if you try to create more than 6, that means something went wrong. So that'll cause an error, but that won't happen because if you do a play and it's got 6, that means it'll do a priority check, and it'll rather send a command of play and replace, which means it's gonna it's basically gonna give it the sound that it's gonna replace this sound with. So it's gonna say, okay, that sound, remove it, put this sound there instead. Same goes for so that then replaces. The only other play command is if you want to play it later, because I can't do a priority check at that moment if you're going to play it later. So if you play it later, it's going to do the priority check then, and then it will figure out if it should do a play, or if it should create a new command, or if it should do a replace command. Other than that, there's when you play a sound with a playlist of multiple sounds, it uses one audio source, so I don't have to worry about creating new audio sources and replacing that way. It just has one audio source that just gets replaced with different buffers. If you want to do a playlist, when you say playlist of sound of more than one, then it will create a buffer for that audio source, because I don't want to go to the buffer manager and try to use that buffer as well. That buffer is for just playing new sounds. But other than that, that's about it. That is all the 5 different demos that all work. If you have any questions, you can get in contact with me. Otherwise, that's it. That's the 5 demos, and they all work the way they should.